Now we will see more about coercion. There is a thing called explicit coercion in R programming. As I showed you some examples earlier in the previous case, when we try to add a numeric and a character into a same vector, you will see that it converts into a character vector. Now in this next case, I'll show you about explicit coercion. Here you can define what the object can be. So an object can be explicitly coerced from one class to another using the as.star function. The star actually defines like what you want to add in that. For example, Control L will clear the screen. I am adding a integer value to x. Now class of x will tell me what value is there. It's a numeric value. Pardon. I've added a numeric value to class x and the class of x is giving me that 1.6 is numeric. Now what I can do is that I can convert this numeric into a logical or an integer. So if I try to do a as dot numeric logical of x, it will turn that 1.6 into true, which is actually any number greater than 0 will be declared as true. If it is 0, it will be changed as false. Now this is called explicit coercion, as a numeric is converted into logical by using this as dot logical of x function. Now the same way you can create as dot numeric, as dot logical, as dot character, as dot complex. You can coerce any class of object into a different class using this explicit coercion function. Now we will see about a thing called nonsensical coercion, which means there is no logic in what we are coercing. For example, if you are converting a character vector into a numeric vector using as.numeric of x, it will return NA, which means the coercion cannot happen as a character cannot be converted into numeric. Again, the same way, if you try to do the same thing for as.logical of x, you will get NA again, as this kind of coercion cannot happen. Now we'll see about matrices. So matrices are vectors with a dimension attribute. The dimension attribute is nothing but it itself is an integer, as you can see where I'm pointing the mouse, 1, 2 and 3, which indicates column 1, column 2 and column 3. This is called as a dimension attribute, which defines as the first column, and this is denotes the first row. And NA is located at 1 cross 1, which means it located in the first place, first row, first column. So this is the dimension attribute which every integer vector will have. So for example, here I want to create a matrix. The function for creating a matrix is matrix of the number of rows and the number of columns. I'll show you a clear example. Clear the screen. Now I want to create a matrix M, which will contain the number of rows equal to 3, comma, number of columns equal to 3. Now the matrix is created. As the matrix is not filled with any of the values, the matrix will display only NA in all the places. Now you want to see the dimension of matrix using dim. It will tell you the number of rows and number of columns for the matrix M. Here it is 3 rows and 3 columns. This is the dimension attribute is specifically for a matrix. Now which you can use the function attributes of M to display the same dimensions and other attributes as well, but here we don't have any other attributes, we have only the dimension. So it displays 2, 3 here, and in this example it will display 3 and 3, which means there are like 3 rows and 3 columns in the matrix. Now we'll continue with the matrix. So we created a matrix with no values inserted, just declare the number of rows and number of columns. So what if I want to add a set of integers into that? So it is constructed column wise, which means when I try to add a integer sequence in this matrix, it will start from the upper left, it will fill values till it ends. So let's say I want to add 6 integers into a 2 cross 3 matrix. It will add 1 in 1 1 and 2 in 2 1 and it's so on, 3 in 1 2, 4 in 2 2. I'll show you the clear example here. Now I'm creating the same matrix where I wanted to insert values 1 to 9 in a 3 cross 3 matrix. One should be familiar with the concept of matrix to understand what exactly happens here. This is a 3 cross 3 matrix, so which will contain 9 values, and the 9 values will be integers added to it. Now when I display M, you will find that 1 2 3 column wise added, 4 5 6 and 7 8 10 all column wise added. Now we'll continue with more. We created vectors earlier using integer sequences. Now, is there a way to convert this integer sequences into a matrix? There is a possibility that for a vector, there is a dimension associated with it. So when you change the dimension, it will automatically change into a matrix. For example, there is a matrix created, there is a vector created, which contains the values 1 to 9. Now, I want to convert this vector into a matrix. So how I can do that is change the dimension of this matrix to contain, just change the dimension of this matrix. So now this vector has become a matrix. Next we'll go with C binding and R binding. So these are concepts associated with only the matrices. Either I'll explain you in detail about this. Matrices can be created by column binding or row binding with C bind and R bind functions. So these are functions. C bind is nothing but column binding and R bind is nothing but row binding. Let's say there are two integer vectors which contain the values 1 to 3 and y which contains 5 to 10. Now when you display x, it will show you 1 to 3, and when you display y, it will show you 5, 6, 7, 8, 9 and 10. Now I want to create a matrix which will contain the values of x and y in a column. How can I do that? So if I use a column bind of x comma y, it will give me this. Now as you can see here, x is a vector with only 3 values and y is a vector with 6 values. So when I create a column bind, it basically takes x and y as two columns and add it together in the matrix. Now x becomes one column and y becomes one column. As y had 6 numbers, it displays the values 5 to 10. But x, in the other hand, it had only 3 values. So what happened is that the same values are replicated in the next cells also. So x has 1, 2, 3 and the next is 1, 2, 3 again. Now this is called C bind. Now if I want to do a R bind of the same x comma y, I'll get this, which will have same but in a columnar in a row fashion. 1 2 3 1 2 3 in x and 5 6 7 8 9 10 in y.